We have one section from chapter 9 to pick up. That's called L'Hôpital's rule. It helps us evaluate limits in a way that we weren't able to back in chapter 2. So to get ready for this section, take these 3 limit problems at the top of this paper and try to evaluate them using the techniques that you remember from chapter 2. So pause the video and try that now. We'll get to the second 2 a little bit later, but just notice that the first question goes so fast because there's no problem. This function x squared minus 4 over x plus 2 is very well behaved near the place where x equals 7, so you can do a substitution in, no problem. The other 2 problems, we end up with 0 over 0 or infinity over infinity. Each of those is an example of what we call an indeterminate form. We can't say what the limit is when we end up with 0 over 0 or infinity over infinity until we try some of the algebra techniques that we remember back from chapter 2. So, L'Hôpital's rule is a method that we can use, an algebra method we can use. It's like a calculus / algebra method we can use to evaluate a limit if substitution yields an indeterminate form, either 0 over 0 or infinity over infinity. So here's what we know. Let's focus here on the 0 to 0 case. If you try substituting in to a limit problem, in this case, I'm going to plug a in for x, and I end up with 0 over 0. I can try finding f prime of a divided by g prime of a. If that exists and there's no problem, then that's my answer. So we're going to try that middle example. We already know the answer is supposed to be negative 4. Let's try it using L'Hôpital's rule. So instead of finding, when I plug in negative 2 for x, I'm going to get 0 over 0. Well, in this case, f of x is x squared minus 4, and g of x is x plus 2. So f prime of x is 2x, g prime of x is 1. And so the limit as x goes to negative 2 of x squared minus 4 over x plus 2 is the same as f prime of negative 2 over g prime of negative 2. So f prime of negative 2 over g prime of negative 2 is 2 times negative 2. G prime is a constant, it's 1, so no matter what I plug in, I get 1. Final answer, negative 4, which is the same as what you got when you used algebra. So it's a cool thing. If you have a limit that you want to evaluate, and using substitution gives you 0 over 0, you can try L'Hôpital's rule. So that's what we call the first form or the weaker form. It turns out that L'Hôpital's rule is even stronger than that. You can continue to take derivatives. If you try to use the first derivative like we just did, and you end up with 0 over 0 again, or you end up with infinity over infinity, you can keep taking derivatives. As long as you keep getting indeterminate forms, you can keep taking derivatives until you finally get an answer. So here I have the limit as x goes to 0 of 1 minus cosine of x over x squared. If I try substituting in 0 for x, I'm going to come over here to do that on the side. If I try plugging in 0, it's going to be 1 minus cosine of 0 over 0 squared. Well, cosine of 0 is 1, so it's going to be 1 minus 1 over 0 squared, which is 0 over 0. It's an indeterminate form, so I'm going to try applying L'Hôpital's rule, this stronger form. That's going to equal the limit as x goes to 0 of, I'm going to find the derivative of the numerator. So 1, the derivative of 1 is 0. The derivative of minus cosine of x is sine of x over 2x. I'm going to imagine evaluating that with 0. So sine of 0 over 2 times 0. Well, sine of 0 is 0. 2 times 0 is 0. This gives us another indeterminate form. So I'm going to keep going. I'm going to take the limit as x goes to 0. Derivative of sine x is cosine x. Derivative of 2x is 2. Now when I replace x with 0, I'm going to get cosine of 0, which is 1, 2, 1/2. So I've used the stronger form of L'Hopital's rule, and I have been able to find an answer, where using algebra here would have been very difficult. Just notice that I could be taking the limit as x approaches infinity or negative infinity. It doesn't have to be, here it was a 0. It doesn't have to be a constant. It could be infinity. So we're going to do that third example from the top of the page here using L'Hopital's rule. When we already know the answer is, what, 1/3? So this should be the limit. Well, I should say, if I try replacing x with infinity, I'm going to get infinity in the numerator and infinity in the denominator. That's an indeterminate form. I'm going to take the limit as x goes to infinity and use the derivative of the numerator and denominator. Derivative of x squared minus 4 is 2x. Derivative of 3x squared is 6x. If I try replacing x with infinity, I'm going to get infinity over infinity again. Use L'Hopital's rule again. It's the limit as x goes to infinity of the derivative of 2x is 2. Derivative of 6x is 6. 2/6 makes 1/3. Final answer. Sometimes at this point, students get mad that I didn't teach you L'Hopital's rule back in chapter 2. It's way easier to find derivatives this way than all those sort of algebra acrobatics that we use. Rationalizing the numerator, all that kind of stuff. So just reflect for a minute, would you? Why is it that I didn't teach you L'Hopital's rule back in chapter 2? Write your answer here. It's not because I was trying to make you tough or for your own good. There's an actual reason. But if you think back to chapter 2, you'll figure it out, and right here. Okay, so now you're going to answer these multiple choice. Practice using L'Hopital's rule. And, or like if you feel really strong about the techniques that we learned back in chapter 2, you have lots of choices now for how to evaluate limit expressions. Okay, associated with L'Hopital's rule, we have to talk about what sometimes is called to, sort of jokingly, L'Hopital's trap. So one of the parts of the math practices for AP Calculus is that before you use a theorem, before you use the intermediate value theorem, before you use the mean value theorem, before you use L'Hopital's rule, you stop and check and make sure that the conditions for the theorem to hold actually hold. So would you keep that in mind? And I'm going to actually have a picture out of your textbook so you don't have to go get your textbook. We're going to do page probably is not correct. I'm going to show you this question from your textbook. It's titled L'Hopital's Trap. We're going to answer part B. So this is this question here. It says, here's f of x, 1 minus cosine x over x plus x squared. It is not that up there. So they haven't given us a graph. They haven't given us anything except this function definition. And they say use tables or graphs to figure out the limit as x goes to 0. Well, this is the teacher's edition. You can see the answers there. You could use your calculator. You could graph it. You could make a table. The limit is 0. So the question is here for part B. Here's somebody who comes along. They've just learned L'Hopital's rule. They thought they were doing everything right, and they get the answer 1/2. We know the answer is not 1/2. So can you figure out what went wrong with their application of L'Hopital's rule? So I'm going to leave it to you to go back and reread the definition for L'Hopital's rule, the stronger form, and see if you can come up with what the error is. We'll see you back in class.